Okay, Shabab. حياكم الله. I would like to welcome you all to this course. This is EE380 Control System. The course is very interesting course. I hope, to see you in person. Honestly speaking, we would like to see you in here on campus. Unfortunately, with this pandemic, things are changing. Alhamdulillah, we are in good health, and I hope everybody is in good health. We quite adjusted to this mode of conducting lectures, but still seeing you in person is much better. Definitely more interaction, but we have to live with it. Luckily, I think we will be, at least we will be seeing you in the midterm exam and the final. I hope after the mid of the semester, they will allow everybody to come back to school, and we will be seeing you then. Until that time, the class will be conducted online. We will be using the Zoom platform. Okay. And as I said, my name is Samir Al-Bayat. I taught this course for quite some times. I'm professor at the Electrical Engineering Department. The course is a very important course in our life. It's, it is, in every day we are, seeing, working with, control system. There are many physical systems, okay, we are dealing with. However, at the same time, we are using a lot of mathematics in the course. So the course sometimes, it needs a lot of mathematics, and maybe we have to relate, those math models to the physical system. Okay, so some information about the course. Okay, my office hour, I'm teaching two sections. Section at 10 to 11 and from 11 to 12. The day before, I think yesterday, Professor Ibrir, he called me and he said he will be teaching a third section. The department decided to add one more section, and I think it is at 11 o'clock as well. Okay, so we will be having three sections. After the lecture, I will be having my office hour. Of course, you have to take an appointment. You have to inform me that you would like to meet me, because otherwise, it doesn't make sense. I will stay online, okay, and nobody will show up. So if you need me, please either send me email or privately send me, message through the WhatsApp. Okay, and I will be more than happy to help you. If this time is not appropriate for you, we can do some other arrangement. Okay, the textbook which we'll be using is the Modern Control System 13th edition. I hope all of you have received it, but I don't know, the people who are far away from here, I don't know. Did everybody receive the textbook?
No,
Doctor,
not
those
yet,
who are
doctor.
outside Tehran far about 200 kilometers did not receive the textbook, and they have to receive it by mail. If not, go there physically.
Okay, okay. Well, even though, look, the notes are good, but no matter how good they are, you still need the textbook. The textbook will explain the idea more, okay? And also, we will be, sometimes giving questions from the textbook. Maybe for the first 2 weeks, if there will be a homework, I'll try to, put the homework, even if it's from textbook, I will copy that portion and put it in there until, inshallah, within 2 weeks, everybody will receive his textbook and we don't have any problem. Okay. We will be, I just put in here 2 textbooks as references. Okay. Well, Ku and the other one by Ogata. But look, in the web, you can have so many, textbooks, so many lectures. In recent years with the technology now, things are open and there are thousands and thousands of references in the web. Okay. Well, let me, you are taking this course. This course is a required course. Okay. Because it's important, so they put required. But even if it's not required, it will be interesting to, to take such a course. Now, can you tell me what is this course is all about? What's a control system? And
as far as I understand, Doctor, we have 3 stages. We have modeling, and then we have analysis, and then we have design.
Good. This is what we are going to study in this course. But what is it? Give me an example of a control system. I mean, what you have said, you're right. In studying the course, we will, doing the analysis, doing the design. But what is it? Yes.
And for instance, an example from the daily basis in action, like when we drive the car, we do a control system spontaneously, basically.
Exactly. This is good example. Right. Any other example, Shabab?
Yes.
Refrigerator, Doctor, like heating and cooling the objects.
Okay. Again, this is another example. What else? The room temperature.
The shower.
The room temperature, isn't it?
Yes.
This is one. How about more? How about, the traffic light? Is the control system?
It is, of course. It is.
Yes, it is giving you go to the traffic light, to the intersection, okay? You stay for a certain amount of time, then the light become green and you will move. Okay, some of them, we call them an open loop system. That basically, they are not smart. The traffic light is not smart in the sense that, you have one part in the traffic light is jammed, a lot of cars, while maybe other part, there is nobody in there. In the smart traffic light, there is a sensor. It will sense if one of the lane doesn't have any car, it will not give it the green, it will give it red and distribute the other time between the other lanes, which are, crowded. So you can think about the traffic light is a control system. Okay, what else? The teaching method is a control system. Okay, your professor give you the first exam and everybody is flunked. What will happen? Okay, we have to review. We have to see where's the what went wrong. Okay, and do correction. So look, everything in daily life needs control. Now, in recent years, look, drone. Okay, drone has many, application. One of the applications you will see in wedding, within the, hall, you will see the drone up and taking, photos for people. So life is changing and control is there. Think about the assembly line. Okay. For example, if you take the Pepsi or any other drink, how does it work? How do they fill the can? How do they fill the can?
They have a specific volume for each can, right?
Yes, but what's important?
Yeah.
What's important? You are absolutely right. But what's important when the can arrive at certain place?
Yes.
the faucets of the which will fill the can will come precisely
Exactly.
with the amount and will be out. Then
Yeah.
move to another place. So this is all of those are controls.
We can say actually, Doctor, in this example, we have more than one control system. Yeah.
Definitely, definitely. It is definitely. There are many. But what I'm saying, you know, control are used in our daily life. Okay. So in a way, this is think about it in this way. The concept is to maintain a variable of process at a desired value while rejecting the effect of outside disturbance by manipulating another system variable. Let's take the example of the car. One of you said the car. Suppose you are going from here to Riyadh or Jeddah or anywhere. Okay, you will use cruise controller. Of course, these days you cannot set it on 180 or 160. To Riyadh, at most what, 140 now with Sahir, Barakat Sahir?
Yeah, 140 in a certain place. You have to be alert about it.
Yes. But let's say, okay, you set it on 120 to be the safe side.
Yeah. 130, Doctor, it's acceptable, I think 10% or to 11%. 130.
Okay, whatever.
Yeah.
You would like to maintain a certain speed level. You move in the road is smooth, and all of a sudden, suppose you want to go uphill. What do you feel, what will happen in the car if you go uphill and you want to maintain the same speed?
It will
It will be
increase.
slow.
You will feel that the accelerator is pushing, you know, I mean,
Right.
pumping more fuel. You are burning more fuel, isn't it?
Exactly, yes.
To keep the speed the same. While if you go downhill, what will happen?
Kind of the accelerator
There
and
will
the
be brake.
actuator.
Yeah.
Yes.
There will be brake in the system.
Yeah. This is negative feedback. Yes.
The variable you want to maintain is the speed, regardless whatever you have. Okay. In the room temperature, you set your set point at, let's say, 20 degree. Okay. Maybe if you are the father of the house, you will set it on 22 or 23 because you'll pay more electricity. Okay, the children want to have it very low, and you want to have it a little bit comfortable. But anyway, you set on the desired point. Then there is sensor in the room. It will sense if the actual temperature more than the desired one, it will send a signal, and the compressor will work until the temperature will become 20, let's say, which is equal to the desired one. Then the compressor will be off, and so on. So in this case, your variable, you want to maintain the temperature. Okay. One more example here. What do we have in here in this example? What does this example represent?
This is like a filling tank with a certain, altitude, right?
This is simply, what is it? Water tank. At home, everybody's using water tank. You would like to maintain H, the height of the water in the tank, constant, regardless how much you are taking from here, by adjusting the opening of the second valve, or the input valve. So this is, we will, we'll be talking about, different type of controller, but this is a control system. Any question here? Any question, Shabab? Okay. Well, one of you mentioned what we are going to study in here. We are going to have the roadmap for the course. We will be starting by modeling.
Doctor?
Tafadhal.
I'm sorry, but did you upload the slides?
Yes, it's already uploaded.
Okay, thank you.
Okay. Okay. So the first thing is modeling. So it's modeling. Can somebody tell me what is modeling?
Converting the actual, system to equations, kind
Exactly.
of.
Exactly. You are absolutely correct. You are absolutely right. Basically, you have a circuit, let's say, since you are all electrical engineer and you are familiar with the circuit. You are given, let's say, one source, and I have one capacitor, one resistor, and one inductor. And you've been asked to find the, let's say, the voltage.
Differential equation.
You have to have equation. So the modeling, okay, you have physical model, you have physical system, you try to write a mathematical model for it. Okay, so the first model usually is the differential equation model. If I have, let's say, one inductor, one capacitor, one resistor, what's the model of the system will be? What the order of the system will be?
The first order.
What? Capacitor.
Oh, you have three. Yeah, it will be second order.
Second order.
Second order.
RLC circuits.
So if I want to represent the system, I will have a second order differential equation. Okay, if it is, electric system, I will be using KVL and KCL. If I have a mechanical system, what do I use? In mechanical system, suppose I have, mass and spring, and I'm pulling the mass. Okay, what do I use? How do I write my model? How do I write my differential equation? What do I use? Well, in the case of electrical, we said KVL and KCL. What about mechanical system?
Newton's.
Newton's.
Third law will be also, yeah.
Okay, Newton's law. Summation of the forces equal to, mass times the acceleration. Okay, if you have electromechanical device like, motor and motor, in there you will have part of it electrical and part of it mechanical.
Combination of the two.
The combination of the two. We will start usually by the differential equation model. Then we'll be talking about transfer function. What's transfer function of a system?
It is the output over the input in Laplace.
Okay, and setting the condition to 0. So
exactly.
In the differential equation, I can have another model called transfer function. The block diagram is nothing more than a black box. You have an input and output. Whatever inside the black box could be transfer function, could be differential equation, and so on.
Transfer function, Doctor, it's the impulse response in Laplace, right?
What is the impulse response in the block diagram?
And the Laplace, which is the transfer function.
Yes.
If we take the impulse response and we convert it with Laplace or transform it to Laplace, we get the transfer function, right?
Yes, the transfer function. Look, we will see. Okay, what we are going to do in here, either we will get the transfer function from the differential equation, or you could, if you have, as I said, an inductor. Okay, what is the impedance of the inductor?
G omega L.
Or in the Laplace transform, SL, isn't it?
Right.
So we can, you can directly write it, or
SL.
as you said, if you have the impulse response, take the Laplace transform of the impulse response, that will give you transfer function. So,
but Doctor, here we have to have the system, it has to be linear and time invariant, right? And we have to have some conditions in our system.
We say that the system has to be linear for transfer function.
And time invariant, I meant to use what we have studied in 207,
Exactly. So basically, we are expanding on 207.
I see.
Okay. We are not going to study, we are not going to talk about the, Laplace transform. I assume that you know Laplace transform. Maybe I'll put, some question in the homework on Laplace transform, but I'm not going to go through Laplace transform. I assume that you already have it in 207. Now, the last model is state variable. You know what state variable model? Okay, state variable model, maybe it's new for you. The state variable will come and define the state variable model, but simply, if I have, as I said, circuit with an inductor and capacitor and resistor, it is second order model, which I have a second order differential equation. Okay? In the state space model, state variable model, I will convert the second order differential equation into two first order, and that I'll call state variable. We will come and define it. So basically, we will be spending 35% of the course in the modeling. Okay, once we build the model, we would like to analyze the model. Is the model good or bad? What do you think? What kind of measure a system is good system?
Stability.
Stability. What is a stable system?
How much can you control it?
The real part of the balls has to be in the negative, because at the end of the day, the solutions of our differential equations usually is exponential, right? So if it's in the negative part, it will be killed at the, at infinity.
Okay, this is great. What you are saying, absolutely correct. But what you are doing, you are analyzing, you are testing if the system is stable or unstable. My question is, what is a stable system? What you gave me, what you described, and that's what we are going to do. How do I test if the system is stable or unstable? But before that, what is a stable system?
A stable system, Doctor, we can define it, that gives us what we really need, and it does not go mad, in simple terms.
Okay, and you are right. You are absolutely right. Let me put it in a little bit. This is one definition. By the way, the stability has many definitions. The one which we are using in this course, it's called bounded input, bounded output. Meaning, if I have a system and my input is bounded, if my output is also bounded, it doesn't go mad, as you said, my system is stable. Otherwise, the system is unstable. Okay?
We have taken this in 2 seminars.
Yeah. So, but this is, look, this is one type of stability. We'll come later on, we define other definition. What we are concerned with is this definition. Bounded input will give you bounded output. Okay? We will, do, the testing for stability. It has many methods of testing. Simply you said, okay, I can factorize the denominator of the transfer function, and if my roots are in the left half plane, then my system is stable. Otherwise, my system is unstable. But I can do that without, finding the roots through what we call Routh-Hurwitz test, through root locus, in the frequency domain, Nyquist, and so on. Okay. There is another concept which we are not going to, do in this course. It will be done in other in advanced course. It's called controllability. Controllability basically simply is, can I control certain system or not? If I can control it, I will say my system is controllable. Otherwise, my system is uncontrollable. The other one is tracking. Okay, in time domain and a frequency domain. For example, we mentioned the, filling the can of, liquid or Pepsi or whatever. I have to be precisely position my can beneath the faucet of the liquid. Otherwise, if there is a shift in it, what will happen?
The liquid will be spilled
The
outside
liquid will
the...
be, you don't fill the can, and the liquid will be out. So there's a damage. So this is, in a way, tracking. I want to have, certain, or tracking, you are tracking certain airplane. Okay, rockets are, tracking, an enemy airplane. Okay, so we will be, okay, this will take about half of the course will be spent on the analysis. Well, sometimes we need design. Okay, if my system is unstable, or my system, I want my response to be a certain time, you know, I mean, I want to make my system respond quickly, fast, and the system, it doesn't give me that speed. I will put what we call a controller. The controller hopefully will, you know, do the job, will help in doing the job. Of course, I mean, it's not always possible. I mean, sometimes certain system, we cannot, no matter what you do, it is unstable. Okay, so we will be spending, you know, the rest of the semester, which is 15% of the semester, in, you know, the design. We will be talking about the PID controller, proportional integral derivative controller, lead lag controller, and others. It depends on the time. So this is basically the roadmap. You will see the roadmap, okay, as we move. Okay. Well, what are the system outcomes? Any question?
Yes, sir. Is it harder to analyze or design the control system?
Well, definitely design is harder because the design, look, the design is not unique. Okay, you would like, you know, to design in a certain way. Look at the cars. Look at the cars. The cars, you know, they have different design. You know, in the 70s and the early 80s, nobody cared about the fuel economy. So they don't pay that much of attention to the shape of the car, the aerodynamic of the car. Now it is very important. And when you want to buy a car, you will look into, you know, how many miles the gallon will give me of gasoline. It depends on the design. So the design is not unique. Everybody can do his own design.
Doctor,
Yes.
for the design, usually when we have a problem in our life, we start with design, right?
No, no. You don't start with the design. You start with what do you want?
Objectives.
Objective, exactly.
Yes.
I want to achieve a certain thing.
I see.
Okay, then, okay, which system can do this?
Requirements. You collect the requirements.
The requirement, exactly.
Yes.
The requirement. I need certain speed of response. I want certain, sometimes what we call, later on we'll come to, we call it overshoot. That how much, you know, I will allow in my system. Okay, suppose I have step response. Okay, the system doesn't go directly to the step. Sometimes we'll go over the step and come back to the step. How much you tolerate.
I see. The difference.
So this is we call the objective and the specification. Okay, suppose with this specification, you came up with your model, and then you translate this model, you fabricate this model, and it give you your system. Now you test your system. Does it give you what's required or not? Okay. Sometimes you can adjust the parameter within the system and it will do the job. But sometimes no, you need another object. You need another. So the design basically, no, it is the last stage. The first stage is that, you know, the specification or the objective, what do you want to achieve? This basically.
What is BID, Doctor, here?
What is what?
BID. The
PID, okay. Proportional. So basically, proportional, you will have a component that's, you know, pure gain. Okay.
Pure gain.
Amplifier.
Amplifier, I see.
Amplifier.
So whether it's active amplifier or passive amplifier, it doesn't matter.
No, amplifier, just pure amplifier. No, just amplifier, resistor. Okay. Ratio. between two things, you know, I mean, gain,
Passive amplifier.
okay? That's basically I have a block input, let's say X, Y, and this is K. So Y equal KX. Whatever X, it depends on the value of K, I can amplify it.
We don't really consider K in this course.
K?
We don't really consider K. Yani, what is K?
K is a controller, a pure gain controller.
Pure gain control. Okay.
The I, the integrator, stand for integrator, and D stand for derivative. PID, proportional integral derivative. We'll come to it in detail. Okay? Now, what are the outcome of the course? The outcome of the course, first of all, by the end of the course, hopefully, okay, you will be able to understand what's feedback. Okay? What's the feedback? Basically, feedback, I'm controlling, I'm, checking, I'm comparing my output to the desired input. If it is exactly the same, that will be great. Otherwise, I will send a signal to my process to adjust such that I will get the desired output. Desired input, sorry. Okay? Determine the physical model. For example, I have a circuit. Give me the differential equation model or transfer function model or state space model. Or if I have, mechanical system. Okay. In here, we are going to talk about mechanical system, electrical system, electromechanical system. If you are, by the way, control system is not limited to electrical engineering. You could be a mechanical engineer and you need control system. You could be a chemical engineer. In chemical engineering, they have also control system. System engineering, they will study control system. But the difference between all of them is the application. Where do you apply it? How do you apply it? But the main concept, for example, feedback or stability or desired output, all of those, desired input and output, all of those are common. So you should be able to model certain physical system. Of course, we are talking about something simple in here. Solve, okay, you have a differential equation, definitely in 202, and in differential equation system, math 202, they taught you how to solve differential equation. So we could have the state variable, which is, a set of first order differential equation. How do you solve the differential equation system? You will hopefully by the end of the course, you know how to do that. I'm sure by now, maybe you know how to do it. Okay. You would like to determine the frequency domain responses of first and second order system. Time domain and frequency domain. For example, in circuit 1 and 2, you study the first order circuit and second order circuit by switching, okay?
Right.
If you have a switch in a circuit, you charge your system, and then let's say you open the switch. There's no input. You observe how does the response look like. So hopefully we will be studying the second order system in this course. We will be focusing a lot on the second order system as well. You will be able to determine the stability of the system. As I said, there are many methods. We have what we call Raoult-Hurwitz. We have root locus. We have in the frequency domain Nyquist, and so on. So hopefully, by the end of the course, if you are given a system, you should be able to analyze if the system is stable or unstable. If you cannot analyze and you pass the course, it means that there is something wrong. Okay? Because this is, a heart of the course is stability. Yes.
For the delay, if the system has a delay,
yes,
will we consider the stability with the delay?
Well, definitely, yes, you can apply it, even though we are not going to, deal with it a lot, but yes, you can. Because in the delay, what will happen, okay, your transfer function, the all of the system will be the same. What you are going to have, you have delay, an element of delay. We are not going to, honestly speaking, we will be focusing on the, the simple system without delay. But yes, you could. I mean, you could study the delay. This is a good question. Excellent question. Okay. We will not, the main focus in here on the system without delay. But I mean, once you have the method, you can modify it. As a matter of fact, I think in, Nyquist, they touch into the delay, Nyquist and body plots. Okay. Well, course outline, this is, look, the course outline, if you go to the roadmap, we are translating the roadmap into the specific, how do I, what I'm going to do and how do I go about it. So this is, exactly, and I'm not going to go through it. This is exactly the roadmap which we have. Okay. If you look into it, the differential equation model, this is in the modeling, transfer function in the modeling, the signal flow graph in the modeling, state variable in the modeling, state transition in the modeling, all of this in modeling. Then the performance the performance, no, we start, in the analysis. Okay. Stability in the analysis, root locus technique, frequency method, all of them in the analysis, and then the final thing, design. So we are translating the roadmap into the specific topic which we will be covering, and that is what we are going to cover. Well, I think this is important. This is the grade distribution for the course. I put this distribution, and well, most likely it will stay, but there is a possibility of slight change in it, depending on whether we will be having more than one midterm. I think we will be having one midterm, but just in case, if there will be two midterms, then we divide the 20 into 10 and 10. And also, as I said, up to end of last week, I'm supposed to teach 2 sections of the course. Now the department add a 3rd section, which is taught by Professor Slim, and I have to arrange with him if, the grading, most likely is not going to be changed, but just in case, I will let you know as soon as possible. But tentatively, the lab, it will have 20 points as usual. The homework, we will be giving about 8 to 9 homework, most likely 8 homework, which meaning that every other week, you will have a set of homework. I will be having a grader, okay? The grader will do the grading and, so we'll grade all the homework. You will submit the homework through the online, through the Blackboard. In the, beginning of the semester, maybe you will have, 2 or 3 homework a row, weekly, in row. But later on, if you average it, it will be, every other week we have about 15 weeks in the semester. So every other week we will be having, a homework. Then we'll be having short quizzes. Those quizzes are quite related to the homework. Either they will be directly from the homework or something similar. So each homework will cover whatever, the quiz will cover whatever in the homework, in that particular homework. Okay, since the homework is going to be, we are doing online, so the quizzes will be online quizzes. Most likely, I will be giving you during the class time, but I don't know, maybe if I can combine with the other section, it will be after hour. But I think I should keep it, during the class, which will be, easier for you. Then we'll have the project shortly, maybe within 2 to 3 weeks, we'll give you a project. And the project, it's worth 8 points. We will take attendance, okay? The attendance will be 2 points. So if you just attend, you will get the 2 points automatically. In the attendance, basically, we are using, in this section, I'm using the Zoom platform. When you enter the Zoom, okay, At the end of the lecture, I will take a report from Zoom, how long you have been in the lecture. When you enter the system and when you leave the system. For example, in here, I can see I have 28 students. Okay. Okay. There's two things I want you to observe in here. First of all, the Zoom will tell me how many people, but it doesn't tell me sometimes, unfortunately, even though we are, good Muslims, we pray, okay, we go to Hajj, we read Quran a lot, but sometimes when it comes to certain things, we take it easy in it. Possibly, out of the 28, one of you, his name is appearing, but physically he's not there. So please, I know you can do it, don't do it in that way. Sometimes randomly I'll check, but I assume that you are mature enough, you are, you know about ethics. Okay, so please, as I said, if you are attending, you are attending. If you don't want to attend, fine. But don't, try to, misinform the system. The other thing, please, when you enter the Zoom, you will have a name in the Zoom. You will be using certain name. Please do not change your name during the semester, because what I will do, I will take the report, the Excel sheet from the report of the attendance. I will map it to the exact name which I have. Okay. So, and I don't do it manually. I do it through, a software. So the software will read your name in Zoom and transform it. So please do not change it. If you change it, it means that you are an absent. Okay. So please stick to the name. If you want to change your name, send me an email. Tell me, Professor, I'm changing my name in Zoom. So I will adjust my system. Otherwise, it will show that you are not attending while you are attending. Is this clear?
Clear, Doctor.
Okay. The midterm, this time I think we will.
دكتور sorry بالنسبة خلاص يعني we will use the same link that you have sent to us
Yes.
throughout the semester. We don't really need to
Exactly.
use what is called MS Teams, because we have there I think a team there.
No, look, I'm using this is Zoom, and the one which I'm using, it is, licensed Zoom, license copied, which have good feature, as good as Team. Somehow I get used to the Zoom, and I prefer Zoom. So for you, it doesn't make any difference, okay? You are attending, okay? Yes, the Team, it has good feature. I think the names appear directly. You don't have, to map them, okay? But as I said, I'm comfortable with it, and I am running the Zoom for the past 3 semesters. Okay, I mean, this is the 3rd semester, and I don't have any problem with it. It's a good platform, and please, okay, let's. The only thing, as I said, where I realized last time, sometimes when you enter, some of you change their name while entering, and that that put in the attendance, that creates certain problem. Okay. Now the meeting is going to be in person. Sorry, the midterm exam, sorry, is going to be in person, and the final is going to be in person. Okay. The quizzes, definitely they are going to be, multiple choice or calculated formula. Okay. The midterm and the final, it will be mixed between multiple choice and written, definitely. Any question here?
دكتور بس معليش بالنسبة للرابط حق الزوم if you can just put it on the blackboard يعني for خلاص يصير مثلا stationary there عشان
Sure.
الايميل
Yes, yes, I get you. Inshallah. I will let me see how to I'll put a picture.
So,
Yes.
how many quizzes are we going to have?
Okay. As I told you, the quizzes are related directly to the homework. So there will be 8 homework, 80 quizzes. 9 homework, 9 quizzes. 7 homework, 7 quizzes. So they are directly related to the homework. Okay.
Okay.
Doctor.
Yes.
Inshallah, doctor, in the midterm and the final exam, we will have the in-person physical attendance.
Yes.
But if there were obstacles, will you change it online? Because
If there will be what? If there will be what?
they will be online.
If they will be online, we'll do it online. We have, we get, we online. Alhamdulillah, يعني, look, الحاجة من الاختراع يعني. I think يعني, if you go back 1 year ago, like this time, we don't know online, and we don't, care about online, and the university, they don't observe the online that much. When the pandemic came and we have to convert, we converted in no time. Believe me. When they said, okay, the next day do it online, we did it online. Alhamdulillah, we become successful. We are learning. Look, what's important is that, how do you learn? How do you adjust? So they said the midterm will be online. We will have it online. If they said physical, inshallah, I hope it will be physical. I hope all of you will come, not only, lectures, hopefully after 10 weeks. Because
yeah, inshallah, doctor, inshallah.
Inshallah, yani. Like what I'm saying, don't worry about it. We, last semester, I gave an exam and I gave final. And the exam, basically, it will be multiple choice or calculate formula. What we did, there is no backtracking in the sense we'll have one question at a time, okay? And the question are random. And believe me, perfectly. There is distribution, the distribution from 95 to 20. So this will make sure that the integrity of the exams there. Okay. Look, in here, as I said, we want to help you. Last semester, alhamdulillah, yani, all the students passed the course. Okay. And I taught about, I had 60 students, about 10 of them between A+ and A. The course GPA about 2.6. But you have to work. If you don't work, the semester before last, the grading was pass or fail. And one student failed. So if you do great, and I hope you will do great, we will help you. But if you don't want to work, this is totally also up to you, and you will not, nobody will pass the course without putting an effort in it. Okay? Maybe I will stop here. If there is any question before I stop, okay? I'll be more than happy to answer.
دكتور
تفضل.
عندي سؤال بس بخصوص كورس ال 370 إذا ما عندك مشكلة تجاوب عليه.
370
يس
اوكي.
اللي كانت كوميونيكيشن لانه اخذنا في الفريكونسي دومين فانا عندي كونفيوجن مع البولز والفريكونسي دومين اللي اخذناه في ال 370.
Okay. Inshallah, no, you will, the poll basically what will do, okay. And here we will be working most of the time in the Laplace transform domain. The end of the course, we'll be talking about the frequency domain. Inshallah, it will be clarified. I can, okay, look, maybe, if you, I can have a meeting with you whenever you want, and I'll explain, okay, where is the confusion if you want. Okay, I'll be more than happy to do that. Inshallah. Okay, as we move in the course, you will see. Okay, and you realize. What's your name, by the way?
I'm ماجد الحارث.
Okay, Majid. Inshallah, yani, as we move and see if you still have, whenever you have the confusion will arise, I'll be more than happy to sit with you and explain it to you.
اوكي تمام، يعطيك العافيه دكتور.
حياكم الله.
الله
يا هلا
يحييك.
وسهلا.
دكتور، عندي انا
أيوة.
اسئله في الزوم